All right, so we want to approximate the square root of 994. And we know that the square root of 999.4 is very close to 100. And that's helpful because 100 is a perfect square. The square root of 100 gives us 10. So we can approximate the square root of 99.4 using the square root of 100 minus that difference, right? This difference from 199.4. And that difference, if we take 99.4 from 100, we'll get 0.6. So we know that that difference in our x values, what's under the radical expression, what's under that square root, is about negative 0.6. So given this information, we want to create an equation. That's our first step. We created an equation as y equals square root x. Why? Because our radical expression deals with the square root. Had that been cubed root, fifth root, fourth root, we would have wrote it as y equals cubed root, fourth root, fifth root, whichever root we were given. Since we're dealing with square root, our equation is in that format, y equals square root of 100. And we know the value underneath the square root is 100. We're using this approximation to help us make an estimation. So when that change in x is negative 0.6, so when we change from 100 to 99.4, it gives us negative 0.6. That's our change in x, delta x. But what is the change in y? Essentially what we're looking for. We start with what we know. We know y equals square root of 100, which is 10, right? Square root of 100 gives us 10. So we know the value of y. We want to find that first derivative. Now, our original format of our equation is y equals square root x, again, because we're dealing with square root. We want to rewrite that radical expression as an exponential expression. We write it as x to the power of 1/2, and then we take the first derivative. That'll give us 1/2 x to the power of negative 1/2. Now our goal is to find that change in y. So we're taking now the derivative of this y expression as it relates to x. Since we're dealing with two different variables, we have to add the derivative of x to the right side of that equation. So we take the derivative of both sides. We rewrote that exponential expression as a radical expression, that negative 1/2. We put it in our denominator. That gave us the square root of x in the denominator. So we have 1/2 times square root x times the derivative of x with respect to x. Now, that derivative is what gives us the change. So our derivative of x is the same as delta x, our change in x. In addition to that, the derivative of y is the same as delta y, the change in y. And then we just copied down our equation 1, or our expression 1/2 square root x. Now, we want to think about this. Remember, we were given the value of x. X is equal to 100. So we can substitute that value in our denominator. 1/2 times square root 100. We know the square root of 100 is 10. 10 times this 2 would leave us with 20 in the denominator. So we have now our numerators, 1 times negative 0.6, that gives us negative 0.6 divided by 20. If we divide these two terms, we'll get negative 0.03. This is our change in y. So we're going to take this value now and substitute it back into our original setup. Originally, we want to approximate the square root of 99.4, and we said that it's going to be approximately square root 100 minus some value, right? And that change is that change in y that we just learned. We're going to substitute that value, negative 0.03, and subtract, right? Square root 100 is 10 minus 0.03. We'll get our answer as 9.97. And you can estimate this in your calculator. If you plug this into your calculator, you'll see a value that's very close to our answer that we just received, 9.97.